class which has been discontinued. So I was trying to teach about the asynchronous counter. So now asynchronous counter, as the name says, it is not having a synchronization with the clock, right? But still, without synchronization of the clock, we have to have the states changed, right? So what particular procedure it has to follow, and then what type of changes will be done in the timing diagram, right? If at all it is not synchronized with the clock, then what next it has to be? Like one flip-flop and another flip-flop should have some connection. So in this format, right, this asynchronous counter will try to adjust itself. One flip-flop will be adjusted with the other, like one flip-flop's output will serve as the clock pulse to the next one. That means it is like a ripple, right? When you drop a stone on a water, in a water, so what happens? It will start a ripple, and that ripple will go and push the next, like that it will go. So exactly it imitates, the counter imitates that procedure, right? And moreover, most of the asynchronous counter, not most, almost all, will work in the negative edge flip-flop. That means we have two edges. If you remember, I was telling this. This negative edge will serve as the triggering work. That means when the state goes from 1 to 0, it triggers the next flip-flop to do the action. Then like that it goes on. So we will try to analyze this particular asynchronous modes because there is no procedure involved in that. The only clue what is given is the flip-flop are in a ripple mode. They are connected in a ripple mode. That's what the counter tells. Okay, so I'll just take an example of a 2-bit flip-flop. Okay, so I want to generate states like this, right? So this is serving as MSB, this is serving as LSB. You can take AB also, doesn't matter. Otherwise AB I will take, that's easy. AB. Okay, so 2 flip-flops. I'll try to do. Using the same method. Outputs are ready anyway. A and this is right, 2 separate flip-flops. Right. Now I want to make these 2 flip-flops work in an asynchronous mode. Right. That means their clocks has to be clearly defined. Okay. And moreover, the rule is it works only for negative edge. So I need a bubble over here. Right. So now that is the first and foremost thing. A bubble over here. Then afterwards the show starts. How it is, like what inputs has to be provided, what the clock will be. So I'll start with the clock first. Its clock is ready. Inputs both are high as usual. You can work out with your synchronous one. I took the same example. This output serve as input here. As usual, this is the clock of the second clock. Right? This is high or 1. This is high. Right. So this is how. Now you can take A and B as the outputs as well as you can have the clock pulse also. Now what is the analyzation here? First thing is when the inputs are already provided. Okay, this is high. This is for K. So when the inputs are already provided, what exactly it does? This one will react. The second flip-flop, which is called the B flip-flop, it has to wait. Why? Because this has to enter into the 1 to 0 zone. Then only this will react because its clock, which gives the permission for that to work, has tangled with this one. So unless the A goes to this, it won't. Right. So now, to be honest, if at all we can draw the timing diagram of this, then we can understand. So let us consider a clock pulse, a continuous strain of clock pulse. Consider they are of equal width. So this is our clock. Right. Consider this. And most importantly, This is the one, negative edge. If you see, you can just point out here also. I'm so sorry. So this one will be your negative edge which we are supposed to work out. Okay, now for this particular one, your first flip-flop A has to be started. Okay, so now A, right? So starting it is 0. Then afterwards, you can just see it continues to be 0. The next one till the next level. Then afterwards, it is taking 1. It is taking continuing to be 1. Then afterwards, again 0, 0 comes. So clearly, oh, I'm so sorry. So this is the waveform. You can just check out. Don't get confused. It is following the negative edges. If you can check out with the dotted waveforms, dotted lines, that was the actual connections, right? So if you have to work out, now if you see 1, 0, 0, 1, 1, again it goes to 0 in the negative edge. This is how the A works, right? Now what B does, B will work when A changes its transition, right? Clearly understand. So for that, okay, I will be extending this, right? So that it continues to be a pulse train. Okay, so now my B, okay, so now B done. So B will be following A. It has no link with the clockwise. So what is A doing? So 0 to 1. First it will start with 0. So it will go to 1. When it can go? Only when this particular shift is there. This is negative, this is negative, this is negative. So where it will go? It will 0 is there, then afterwards it has to go to 1. But it will go only at this point. Right. So till that level, it has to maintain 0 only because this is how it has to change. No other choice. So it will go to 1. So till this level, it is 0 only. Right. Then afterwards, again it has to. Now this one has to be continued. Okay. So then you can understand and then you can proceed that way. First of all, here, the big mystery is what is happening? The B, which is following A, whatever A decides, then only B will get. Right? Now, definitely there is a mistake in B. Okay, now you can unmute yourself. You should understand that there is a mistake in B. I am not pointing out what is the mistake. Can you identify and tell? I am not getting the states. If you see that, I am not getting the state. A and B together, just see, I am not getting 0, 0. Then afterwards 0, 1 should come. But what I am getting? 0, 0 only is repeating. Then 1, 0 is coming. Then 1, 0 is coming. How? So there's a mistake. Is that correct? If at all synchronous, you are very perfect. Asynchronous, you can point out the mistake. Now heroes and what? Intellectual people, now you can point out what is the mistake in that.
Ma'am, we have to take the counter outputs through QA bar and QB bar.
Why? I don't think so. Why the outputs has to be considered that way?
Ma'am, if we will do so, then we can get the means the pulse 0001.
You are panicking about the states, but according to the diagram what I have shown, the output of this something is acting as an input to this. See, the output is acting as an input to the clock, right? So this B will react only when the clock is ready. But A is acting as a clock to B. So I am going with that. Then also it is not. There is definitely a mistake. 100% I know. Okay, so it went out. This is the best way for you.
Can we collect outputs from different false?
No.
We will collect from 0, 0, then 0, 1 when B is 1.
Okay. When B is 1, we will count. How we can count? Counter should be continuous. If at all we are getting in between useless states, how we will do?
Ma'am,
Yeah.
one thing we can do is that B as MSB. We can make B as MSB and A as LSB.
A as the LSB and B as the MSB. Okay. Then you will get. Then also I am not. So this is what you know. Anybody try? Keep trying.
Ma'am, what if we give B as clock to A instead of A as clock to B?
No, rules won't agree. Rules won't agree. See, I say the ripple is, that's why they are telling a ripple, and that means negative edge. Something is fishy there. That's what. See, according to the rules we follow, we are not getting the states. Rule says that the clock pulse are synchronized. They have to be individual, and the output of something has to be then to this. And as somebody is pointing out, B acting as LSB and A acting as MSB, then also I don't think it will work. See, I am getting repetitions that too. B has to be LSB only. For sure.
If we make B as means MSB, then we can get the desired output. Ma'am, you are not audible.
What happened to that? Why
Okay,
it is not
fine.
audible?
No, ma'am, audible.
Okay. 0, 0, 0, 0. See, you just see. States are getting repeated. Did you understand? Observe that? Here I stop. Continue. Continue this way. I can still proceed that one we have negative edges now. Just check. This one. This particular stuff. It's coming. Right? So now what is happening here? It will continue to be 1 till this place. Then afterwards goes to 0. Is that correct? Check out.
Yes, ma'am.
Yes, now that's all. So what is your observation? Instead of fiddling with us now, you use your brains if you have any. So if you can see 0, 0, 0, 0, 2 times it came. Okay, 2 times. Then 0, 1, 0, 1, 2 times it came. Right? 1, 0, 1, 0, 2 times it has come. 1, 1, 1, 1, 2 times it has come. Did you observe? Yes or no? And every time you just see the dropping of the A is followed, B is following A, that's all. B is following A according to the diagram, negative edges only are taken. Is that correct or not? Just see. I didn't change any one. B is LSB, A is MSB. Clear? Understand from the timing diagram. Is that correct or not? 2 times, that's all. State is repeating. State is repeating. It is the counter is on, but question is it is retaining in the same state for a long time. I can put that sentence. I can clearly put that sentence. It is retaining in the same state for a long time. So I am getting 0, 0 state for a long time, 0, 1 state for another 1-0 stayed for a long time and 1-1 stayed for a long time. That's all. Now what big thing has happened? Nothing big. I mean, nothing wrong also. Do you find anything wrong? Then why? Yes, you can unmute.
But ma'am, if A is MSB, then 00, then after 10 is coming, not to 01.
What is happening? Just come again in mind.
If A is MSB, then after 00 number 10 is coming, not 01.
See, question comes if A is MSB, if A is MSB, it's only your visualization. Your visualization. Which one to take LSB and which one to take MSB, you are clearly taking. Right? You have already fixed that. You are studying like this only. No? A is MSB, B is this one. If you are reversing it, even in the synchronous counter also, you will get different. Don't you feel so? Correct or not?
Yes.
So, same thing. See, 101, 101. It is a both sides same. But 100, you take the LSB and MSB different way. It changes the position. I mean, its decimal notation will be changed. 0, 1, 0, 0. Take that reverse 0, 0, 1. So where is 4 and where is 1? Different. Both are different. Is that correct? Yes or no? So question comes, you are first of all understanding the concept of which has to be LSB and which has to MSB. Then afterwards applying the logic of asynchronous synchronous. Just like that, you cannot enter into the scene. This is what the first lesson of asynchronous. Asynchronous has no rules and regulations. It behaves as it is, just like you guys. Okay, they follow, but output should be perfectly following with the state. Right? It has to follow this state, provided if at all properly designed. Right? First and foremost rule is don't use a synchronous clock. That's all. So everyone will be using the ripple format. That means one output will serve as an output to the next one. Right. Now, small question. If I extend the same thing to another bit, 3-bit counter. Okay. So what exactly will happen? If it is a 3-bit, what I can do? I can take this, act as a clock for this. Right. I'll get a C. Right. This is JC. This is KC. This is right. Now I'll draw the C diagram. So C will be my LSB. So because it's a 3-bit, now I have changed to 3-bit. Now you can follow C. C will be following who? It will be following
B.
B. So you have to follow B. Right? So that means you require your book to be placed like this. This is what the first charm of a asynchronous, because it doesn't have any rules. Try to understand from the timing diagram. Analyze where it goes mistakes. Now you can tell another manner also. If at all this is repeated, you can say that the state is being repeated. Otherwise there's another name also. I am getting some unused states. For example, just see. The name is a little bit different, tricky. This is the required. Okay, so the blue one is the required one. Now this blue one is not required. Still it has come. Why? No choice. My timing diagram is telling like that. Right. So 101 is required here. This is required. This one not required. Still it came. Still it is occupying a position. So 10 it is required. This one not required. Right. So this one required. So this one not required. Okay. So that way also you can see. Otherwise you can think of it is a bonus. It's a bonus and it is the state is extending for a long time. Okay, now if at all you have patience, you can draw the C line. Okay, extend it. Now for that you require a big train pulse. You require a big train pulse. Then your A should be extended, B should be extended, then C you see. Then the C alphabet you see, C bit you see, or the C variable you check. Then how it comes. Whether you will be getting this or not. Whether you will be getting that or not.
Ma'am,
Yeah.
I have a question.
Yeah, go ahead.
Ma'am, if the table is not given and in the question it's said that we have to draw the table according to the diagram, then then
See,
uh,
it's like this. I understood your question. See, what according to the diagram, whatever state comes, right? That is the counter, right? See, diagram is provided to you. You have to identify what are the states you got. That's what you are telling.
ma'am, in the first negative edge, when the clock pulse is first negative edge triggered in
Mhm.
the first, then A should be changed to 1 now.
Not required. So I am counting this also. See why it has to be the negative edge itself. What happened to this first two? See now till here only I have taken now. Okay. You are talking about the 2-bit. So AB previously like this. You are telling these zeros are in a stable state. In the first edge, you have to change it to 1. That's what you are telling. Is that correct?
Yes, yes, ma'am.
Yeah. That way also it can be understood. Why? Because see that is the secondary. Primary is these two zero states are in the timing diagram or not. Why the zeros are not taken into consideration? The start point is this particular zero. So that zero should be visualized. This zero should be visualized. This one, right? If at all, I am planning your way, you won't be getting this double things. Is that correct?
Yes, ma'am. But ma'am, in that way also, it is possible to draw this asynchronous counter. In that case, the MSB and LSB will interchange.
Interchanged, yes. It has to be interchanged. Okay, that means you have to understand this one as LSB, this one as MSB.
Yes, ma'am.
Right? That's all. See, that is what I told. No rules and regulations. Is this one? This is the first introduction where we will give about asynchronous. Asynchronous don't have any set of rules. Okay, it is following the levels of changing. But if at all you don't want to see that, I don't know what is your name. What's your name?
Ma'am, Swaroop.
Swaroop, yes sir. So if at all you interchange that starting with 0, then afterwards moving, that also is possible. But you have to interchange the names of that, right? So that's what Hiranmaya was also telling. If you do like this from A and this one, so first state is 0 coming, I mean 0 coming, then is 1 0 is coming, then comes 0 1. So we are not following it also for this particular case, right? Yes or no? So the number of counts, what it is doing, different states. Okay, this is count 1, this is count 2, this is count 3, this is count 4. Who is stopping? Count is nothing but a change of state. It need not be a what? In a particular manner. The manner what you decide, that diagram only will be the final version. Okay, counter. Then afterwards we will enter the modulo counters. That time I will be telling. Okay, so now, Swaroop, as you told, in the same manner, please complete the C value, right? So we will give that. How the C came? Anybody has done that? Is it stretching? See, for example, C is there,
Yes,
0
ma'am.
and 1. Yeah, it is stretching much, no?
Yes, ma'am.
So where will be the first stretch? I think till here.
When the B is first negative
Yes,
is
and the B
triggered.
false, right? Okay, so you can have here, there are some comments also, asynchronous works with the delayed versions, right? Then afterwards you have a quicker versions also. See, now here, these are the delayed states are coming, delayed states. Like if I take 2 nanoseconds or 1 nanosecond for each count, when the time you get the first state, this will be the first state. Correct? Yes or no? You can check out. So first state will be that. Then afterwards, somewhere after how many seconds? Afterwards, you will get the second state. Then afterwards, get the second state. So that also Swaroop, are you there?
Yes, ma'am.
Yeah. Is that the same one what you are telling?
Ma'am, for some time, uh,
Yeah.
your video is paused.
Yeah. There's something going on. Now it's fine. This is what I was trying. Now just see again. Again I have. Okay. The first pulse, second pulse, third pulse, fourth pulse. Okay, fifth pulse, sixth pulse, seventh pulse goes on. Okay, so now level 0, like level 0, A, I'm talking about A. So it continues to be 1, right? Then afterwards,
0,
what?
0, then 1.
Why 0? That's what my question is. Why 0?
So,
Why 0? That is what everybody, now everybody will question also. Why 0? I understood why 0.
because, ma'am, because uh, A is following the clock pulse, and when
Yes,
clock pulse is negative is triggered, then it will change
it has to
0 to 1
change.
or 1 to 0.
It has to change its state. It's changed its location. Okay. So
Yes,
when it is negative, it has to go to 0.
0.
Right. Then afterwards, it has to again change its state because it's negative edge. So again here, it has to continue till here. Then afterwards, again here, it has to go to 0. Is that correct?
Yes, ma'am. It will follow like this.
It will follow like that. Correct? Now. Okay. Now B. Now level of B. How it has to? B has to observe what? B has to observe A. So B will be observing A wherever its level changes, and that to negative. Okay. So that means what it has to do? It has to change here. Till that time, it is like this.
Yes.
Right. So then afterwards, next it is following A. Okay. So only here it will again go back. It goes on. Right? Now you understand. Now you understand here. Right? B and A 0 0 0 1 1 0 1 1. Is that fine? Why earlier you got a delay? Why now you are not getting a delay? Earlier also I did the same thing. I did the same version, but you got the states repeated. Okay, now I didn't get a repetition. Now did you observe why? This is level 0, level 1. Yes. You can speak. At least
Yes,
clarify
ma'am.
your doubts. Yes. Now what is happening in that? What is happening in that?
Ma'am, I think that in both the cases we are able to make a synchronous counter, but in one case we can make a delayed asynchronous counter.
Yes, yes, that's what I was telling. Last time also what we had, I gave again two explanations there. We are making a same level. I didn't change the MSB also, by the way. I kept as it is intact. This is MSB for me. B is LSB. Is that correct? I didn't change it. Okay, so I am keeping that, but at the same time, I am reducing the delay. In your previous diagram, if you have noted down or in the record, you can keep it. So you can check out how the delayed versions are exactly happening. And here why it is not happening. What has made that shrink here? Only a simple understanding in this one that the starting stable state, okay, your clock pulse, the stable state is continuing to be 0. At the first negative trigger, immediately you have a jump. It is that following here. That's only change has shrinked it. Okay, that means we have a changeover at every negative clock pulse. That is what the thing followed. Same thing is followed there, but the stable states are there, no? 0 0. It continued. So 1 0 0 delay, it crept into others. And another delay, it crept. Don't you see the ripple? Here the ripple I have. Did you get that? Did you get that? How the ripple has been tactfully avoided in this timing diagram, whereas in your previous diagram, you had a counter, but it is in a delayed counter. I didn't change the circuit also. Have you got that? Asynchronous counters are like this. Okay, no fast rules or no hard and fast rules. You only have to understand the tactics. Okay, okay. Now you can have a question to me. Why can't they do work with the positive edges? Can we think of a counter which works with the positive edges? See, pen and paper work. We can think anything. Can we think? Just understand. It is an asynchronous, and we will have a positive edge trigger. Can we have a timing diagram of that? 2-bit only. We'll talk with the 2-bit.
Yes, ma'am.
Yeah, if I follow same. Okay, that means every change I will start. That means I'll start with 0. So immediate change will come here. Correct? Then that will continue till here. Right? Then afterwards, immediate change will come. Then afterwards, you will get, immediate change will come and it will continue till the next positive. Then afterwards, again positive came, again change will come. At a max, what will happen? You will have a shift like this side. Is that correct?
Yes, ma'am.
Your waveform will be shifted.
Yes.
That's all. That's all. It is all about. That's why these words are called timing diagrams. Timing diagrams is nothing but you fiddle with the time. That's all. This one is the master clock. Right. No matter whatever it is, it will generate clock pulses of equal widths. These two are your designs. How the flip-flops has to react, for which timing it has to react, is the automation going on in these two levels. And by the way, if you carefully understand, this high, what I have given for the two inputs, will it be only high? Can I think of giving high to something and low to this one? Can I do that? Because they are external inputs only. They are coming outside, from outside. Can we think like that? Can be, na? Because in your synchronous, what happened? You designed a state equations. Now, since you have already an idea of your synchronous and asynchronous already have kept that in your brain, so you can identify easily what can be done and hardware-wise, which is more easy to work out. Easily means pen and paper work, which can be easily done, and hardware-wise, which is easy to implement. See, fair judging you do. Asynchronous is this and synchronous is that. You are done. Then, which is easy? Both ones.
Yes, ma'am.
Which one is easy? Asynchronous?
Both are easy, ma'am.
Both are easy. You find both are easy. I feel more easier is asynchronous. No?
Yes, ma'am.
Both are. Okay. So anyway, the rules are little different here. That one. See, don't think that only negative edges are used. Some circuits are there which are using the positive edge triggering. But the gist is you should understand the concept here. Okay. Now with the same issue, I'll go for the C also. The C, which will follow B. Okay. Now C means what? I can start with this. It is following B. So over here till that level, this is 0, 0. Then I am going to the negative. Okay. So at this level, it should change. I'm so sorry. At this level, it will change. Is that correct? So now you can see 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. Then 1, 0, 0. Then if you continue, you will get. You will get or not? Just see. No. So we are with the negative edge. So it will change here. 1, changing here to 0, it will change here to 1. Right? Goes back. So now this particular one, at this point, it should change. Is that correct? Right? Then afterwards, at this level, it is at this point. This is 1. Right. So now, if it follows B, So this is positive, so it continues. Here, it's 2, 0. Is that correct? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. That's all. So,
Ma'am,
if
in
it
this case,
yeah,
ma'am, in this case, C should be our MSB now.
why? Why C should be our MSB? What is wrong if at all it is LSB? What? Hiranmai? Is that you?
No, ma'am, it's Swaroop.
Huh, Swaroop. Why? Why C should be your MSB?
Because ma'am, 0 0 0 0 0 0 0 1 0 1 0.
Okay. I was telling like this. Okay, yeah. In this case,
Yes,
if you
ma'am.
are following, yeah, it becomes MSB. C is MSB. Different states. Right. Yes. Good observation. So this one. So you are getting A and B when you did 2-bit counter, it was different. When you did bit A, when you did a 3-bit counter, it was different. Is that correct?
Yes, ma'am.
Yes, ma'am.
Correct. See, MSB, LSB is our understanding. Okay, timing diagrams doesn't understand, no? Timing diagrams doesn't understand. Okay, now, if at all I will not change this one as MSB, what is my counter coming? Retaining that as a what? LSB itself. MSB and this is LSB. What is my counter coming? What are the states coming? They are jig-jag, na? 0, then 1 0 0 came, then 0 1 0 came, then 1 1 0 has come. So you are having
Yes,
even
ma'am.
and odd. Yes or not?
Yes, ma'am.
Right? So our understanding has to make us ensure that which one has to be given to which type of circuit. See, these are all timing signals generated. This will go to a different circuit, this will go to a different circuit, this will go to a different circuit. Okay, so now my question comes, if it all is a 3-bit, according to the timing diagram, you understood that, okay, this turned out to be a MSB. Doesn't matter. Doesn't matter. The states are coming or not, that is what you have to observe. Different states, that too. Whether it is in a continuous mode or in a different mode. Doesn't matter. But did you get 8 different states or not? You got it, right? And if you want in a particular up state, up counter mode, then you go like this one. By default, I did like this. You see? That goes without saying. Right? I was really not concentrating. I was like, by default, my count went like this. Right. Okay. So is it clear? Is it clear? Because we are following a pattern called negative edges. That's all. Then afterwards, we are generating timing signals. Whereas in your synchronous counter, what is happening? Clock pulse will be the main thing. Afterwards, everybody has to follow. Right. Now, there was an issue here. Sometimes it so happens that after generating my 8 states, that means my count is over, I have to restart. Carefully understand. These are not forever continuously done. If you have to restart is completely different from switching off and restart. So my question comes here, if the clock pulses are this many generated and fixed, that means my timing signals will be doing their show or giving their output till the clock pulse ends. Is that correct? Is that correct? Yes or not?
Yes, ma'am.
Right. Now clock pulse is continuously going on. Right. So what happens according to the theory what you have designed, your A, B and C will be continuously generated. Continuously, not in a synchronous fashion, but it will be continuously generated. Hold on. Right. Now there is a separate set going on. Like if at all you take an example of a decade counter. Decade counter means what? You have to count 10 states and again start. But unfortunately, when you take a decade counter which is having 4 bits, it counts from 0 to 50. But I don't want. I have to stop by 10 itself. Is there any way? Think carefully. I'm giving you a logical question. We are having a 4-bit counter design.
Ma'am, we can pass a low signal in J JB and JC using some gates, and whenever there is 10
Yes,
in the
yes,
ABC
hold on,
connection,
yes.
it
So
will be
that means you have to do some kachmich work to the actual design. That means you have to take extra effort so that it will stop and again restart. Don't you think so? That's how the don't cares have come into picture. Right? When the don't cares have come into picture, what does it mean? So from till 10 only I want 9, 10, sorry, 11, 12, 13, 14, 15. They are unwanted states. That's what we should have. Actually, it goes from 0 to 15. That means 16 different states can be generated with a 4-bit. But I stopped at 10 only because decade counter is supposed to stop at 10. So who has told that one? That logic?
Ayushman.
Aishma. So we have to take the help of some external gates. Noted point. Second thing, we have to take that help, and not only that, we have to actually again restart the machine. That means what he is trying to tell is we will take the external gates help and then give them as the inputs instead of keeping them high. Is that correct?
Yes, ma'am.
Right. So for that only we already have for a flip flop a very what we say, we will tell it as a Gini. Okay, we have a Gini pin called clear and preset. Clear and preset. Preset means input only we will tell. Okay, so the flip flops, I am talking about the real design of flip flop. What will happen? Actually, flip flop will be having two important pins. Earlier also I have told clear and preset. Okay, now preset, PR they will tell or PS they will tell. This one, actually, whatever you will send here, high or low, whatever it is, it will retain in the flip flop. This is one flip flop. Consider it is T, JK or anything. So this is called a preloaded. You make it 0 or you make it high. So that was the starting of your point. Right. Apart from this, clock is there. Clock is there. Right. Now, clock, according to the symbol, if it is high and the preset, I load it. This preset means you loading it. Preset, I am loading that one flip flop. So either high or low, I am loading it. So what is happening? This particular flip flop is loaded something and is ready. Okay, now all of a sudden I want to clear it. Clear means what? I can use this pin and put it in the ground. I can ground it. So what is happening? Preset, whatever you have loaded, that will be shoot out. That will be shoot out. That means again it becomes empty. Please try to understand. Loading it, getting it emptied. Loading it, getting it emptied. So who is having the more major power? Earlier we had only clock is the major one, right? No, not necessary clock. Clock will have an understanding only when these two will work properly. Clearing, preset. Always remember. And if at all you remember, starting one, when I have taught you the flip-flops, I told consider some Q of T is existing, then you are predicting Q of T plus 1. Is that the same word I have used, statement? Consider Q of T is there, Q of T plus 1 is predicted. Don't you know, don't you think?
Yes, yes.
Yes. How I will say considering? Considering is a wrong word. No? Actually, it was loaded, preloaded. Okay, it is preloaded with something. Then afterwards, I am predicting the next one. So this is what called a preload, preset, loading. All these are technical words for this particular pin. Okay, either 0 or 1, anything you load, right? And this clear, as long as it won't touch or we won't fiddle it, it will be running the show. Apart from the clock. So clock has an understanding with a clear and clock has an understanding with the preset. Remember that. This is the actual hardware theory behind the making of a flip-flop. Apart from the inputs. If you see, if it is J and K are inputs. They are separate inputs. Inside these three are the major things. Okay, major things. Please try to understand. The major issues are the clock, preset and the clear. These three pins has to be properly utilized. Clock will run the show, till the preset and clear will be constrained by the inputs. Constrained in the sense it should have a predefined version. Clear should be regularly checked out. Clear we cannot just like that till in between when the timing diagrams are there going on. Consider if the clear bit by mistake goes somewhere, it is grounded out. Everything will be stopped. You know that? This is what the clear, what the importance of clear is. So in every flip-flop, only for here clears are not shown, but exactly they are working. We don't have to touch them. Clear is never used unless we are continuously wanting the same show. Right. Now I think I gave the clue. Now what Swarup or Ayushman is telling, you can stop by using gates, right?
Yes,
And
ma'am.
is that the same thing?
Yes, ma'am.
Right. So now
Yes,
0
ma'am.
to 9. Yes. 0 to 9 you will run. Then afterwards when the 10 comes, can I clear it?
Yes, ma'am.
Yes, that is
Yes,
right.
ma'am.
So now how I will fit that gate thing? Just see, 0 is there and then afterwards 9. What does this 9 means? This one, no? Right. Now, simple issue. If these two pins, like if this is QD and if this is QA, if these two are taken to an AND gate, if these two are high, then you take it to clear. Can you see this, by the way? No. Okay, now means it is 0 to 9 ticket count, right? I want to stop the show. I will tell that not to enter into 10. Okay, what is 10 by the way? 10 means what? 1, 0, 1, 0. No? Yes or no?
Yes, ma'am.
9 is what? 1, 0, 0, 1. So what I will do is I follow Ayushman. What he is telling, use something external gates and stop the show. So I will take this particular QA and QD every time. Every time I will make it an AND gate. Every time. For every state I will make an AND gate. You just check. Other than decimal digit 9. Else, rest of the things it is all 0. Check out. If you want, you check. 0, 0, 0. 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 1. This is QA, this is Q. Check. QA, QD, just end them. Just end them. QA and QD. Other than this particular case, everywhere it will be 0. Is that correct?
Yes, ma'am.
Right. Then
Yes.
the thing is very simple. Take the QA and QD every time, follow it through an AND gate. If the AND gate remains 0, continue the show. If the AND gets 1, connect to clear. Clear. You clear it. When it is 1, you can clear it. Okay, you want me to draw the diagram. So if it is clear, if this is you understood this means I can rub it out. Clear word is used more. I will finish this. Done?
Yes, ma'am.
Yes, ma'am.
So now what I can do is very simple. Consider I will take a big box. Okay, my box has 4 flip-flops already inside. Now I don't want to show everything in this method. All 4 are inside. I am not checking out on that. Okay, my only check is I have 4 outputs whose name is QA and QB, QB, QC. Inside the flip-flops, everything is there. Need not show. Right. Clock I am showing as an arrow so that it is understood that according to the synchronous and asynchronous, it is given the negative edge trigger or positive edge trigger. So I am giving like this. And okay. So clock is given. I'll take input. That means preset. My input means nothing but preset for 4 flip-flops. Okay, starting is I have preset it as 0. Okay, there 4 arrows means consider there are 4 flip-flops inside and 4 preset pins are there. I am showing everything in one block. Okay, now this is clear. All the clears are tagged. Okay, all the clears are tagged. Now, this one and this one. If I connect like this, just see. I am just showing a diagram mode how this works. Okay, now every time, now starting of that, the counter goes on. Okay, so I am taking this as decade counter. I am telling this is a decade counter. Okay, decade counter. How? Initially I have input, then every time I am running the show. Clock is given and running the show. Clear will not do anything. Why? Because starting itself is its state is 0 only. So unless its state is changed, it will not do. State means its value. So starting is 0. Right? When the show has started, it is 0. Right? It will change its state only after finishing 9. Is that correct? Because this will give 1. That time it will come. Till that time the clear is 0, 0, 0 goes on. So all of a sudden 1 it will come. That means what it will have? It has to stop. It will stop it. Again, a fresh start will go. Did you understand? Please try to understand here what I am trying to explain. 3, 4, 5, 6, 7, 8, 9. See, all the time the clear, I am talking about clear. Every time it is becoming, all the time it is changing its, being in the same level 0. Only because the values here, this 2 combination is given 1 immediately because of the connection, what we will say, it being level 0, it immediately changed. When it changed, it shows an indication, you stop the show. It tells that you stop it. Again, a fresh will be there. This is how a preset or a clear, this is called preset. The preset, the clear, along with the clock, will try to stop anywhere you want. From this only idea, they have got an award mod N. This is the evolution they got. Because this mod N, now if at all you just tell me, I want to count only 4 states. This is just an extra one. I want to count only 4 states. That means 0, 0, 0, 0, 0, 0, 0, 1, 1, 0, 0, 0. Okay, then immediately I want this to be how I can design with this. This one won't work. 100% this AND gate combination. No? This is just our understanding. So,
Ma'am, CD and gate.
it won't work. Now think some, yes, that's one. Just see. This C and D, like this is A and this is D, B, C. So this one, other than this is how you understood. Did I teach? It's only observation. Observation. How many states you want? Now this one N modulo 4 count. That means 4 different states can be evolved, and again I can continue the same states. So what it happens? It becomes a mod 4 counter. If I use some extra gates, then fit it to clear. Did you see now why did I call this as a genie? These are the miraculous things happening. Preset, clear. They can run the show like anything. Okay, inside design, you keep your asynchronous or synchronous, whatever it is. Better asynchronous. Normally they prefer asynchronous only. Inside, you keep 4 flip-flops, any flip-flop. Okay, then afterwards in a block diagram you can render. Okay, now I want modulo 5. That means I want 0, 1, 2, 3, 4. Then afterwards I should 1, 2, 3, 4, 5. 5 states have to be. These are 5 states. Then afterwards it has to run. What I should do? Think. What I should do? Some extra work has to be done, definitely. It's not necessary I will use only end logic and then do the show. You can have a combination of means different logic also. Are you understanding?
Ma'am, it will be 0, 1, 0, 1, not 1, 0.
So what can be the logic? You can tell. So
BD.
exclusive
And
or see, there are so many gates with us. This is how a digital designs will be very interesting. Every time, no rules. You can have your own designs. This is how the evolution of a asynchronous then mod counters have come. Starting was, see, I'll not take much time because your next class will start. I'll not take, starting was a synchronous counter where the pattern designing was very continuous and repetitive mode. Right, there are rules. We have state equations, we will see the present state, next state, everything. Then afterwards, the theory of asynchronous has come. Right, so asynchronous, you can nicely manage the time delays also. Right, it is delayed version or you can quicken it also depending upon the clock and the input connections and the external connections, everything. Then from there again, this mod counters has come. So how the counters have totally grasped the application of a sequential circuits, I was trying to explain. Sequential circuits, earlier it was only memory, right? Flip-flop, 1-bit storage device. Then afterwards, it came into the generation of different timing signals, right? So now you can understand sequential circuits, how important it takes a role, big role in the hardware designs. In fact, in your every embedded circuits, these are very must. Okay, now think something and then tell, you can tell it tomorrow, right? In the 4th hour, mod 5. Okay?
Yes, ma'am.
Okay. Right.
BD, ma'am, BD.
What is BD?
Ma'am, BD end.
Okay, if you do BD and will it work?
And ma'am, you have, it is not 1, 0, 0, 0, 1, 0, 1. It should be 5 for 5.
Simple one. If at all you can connect A.
On to QC, AP connected to QB.
Yeah, just to connect A. Simple. Just to connect A to clear.
Ma'am, it should be 0100.
Ma'am, for 5. 0101.
I gave these 5 states. Mine C 0, 1, 2, 3. No? Okay, this is not 4. That I know. Shweta, is that you?
Yes, ma'am.
I purposely gave like this. It is not 5. That I know. Okay, sorry, it is not 4, that I know. This state is the ending state for me. This is what I wanted to tell. I don't know. Like this particular one, it will not be in a sequence. I can use any different states, right? 0, 1, 2, 3. See how I should tell numbers and digits. Same. This is called my one. God forbid, yeah. Wait. Simple. I should clear this. This is my A state. This is my B state. This is my C state. This is my D state. This is my E state. I purposely told that this is A, B, C, D, E. E is this only. Okay, my changes are like this. No need in sequence mode. Not required. Don't you think this one is a haphazardous one? What is this value, by the way? It is what? 8. So digit 0, digit 1, digit 2, digit 3, and digit 8 is coming. But 5 different states now for me. Modulo 5 counter. Modulo 5 counter means 5 different states. That's all. So I gave this. But still nobody has understood that. This one with A itself, you clear it. Finish, no? 5 different states you got, 5 different timing signals you will get, and you can end the show. You can again restart it. Is that okay? Okay. Now, if you are telling that B and D, now this is 4 for you. Okay, this is 4 for you in your sequence. Okay, 5 different states. Understood. Now tell me. Now B and D will work.
Only B.
Only?
QB.
Only B.
Only B.
That's all. Only B, na? Will it work?
Yes, ma'am.
Yes, ma'am.
See, that's the reason I gave the clue like that, and then after the see. Sometimes it so happens you just require a changeover. That's all. You have to stop the flow. Right? Required easy? It's everything, not necessary. 5 different states. Modulo 16 counter. 6 count, mod 16 counter. How do you do? Modulo 16. Then you should question me, ma'am, which state will be the starting state. Okay. One. If my starting state is this. Okay, my ending state is this. Okay, so this one should be generated 1010. Then what is this one? 8, 9, 10. Okay, 11. 1. Okay, then 30. 40. Then again 1010. Now I want only these states. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. This is also mod 7. Mod 7. It is called mod 7 counter. But it has to be specified. Your starting states is this, ending state is this. You do the sequence in between. It has to be mentioned. Okay, mod 7 counter it is. Now, how I will start? I should start, this means I have to put that in the input. Always remember. 1, 0, 1, 0. That should be preset. Right? And it should run the show. After this, it has to again give a clearance to the preset. You load the fresh one. Fresh one. This is rare. First load will be there. Then afterwards, it has to run the show. Got it? Now you tell me where I will stop it. This is already loaded. Now tell me how I should do. Till 111 now. Are you getting the clue? Am I there in the middle?
Yes, ma'am.
Yes. Now see, everything if I input is enough. All the outputs I will go and give it to AND gate and then add it to clear. Will it change? Mod 7 counter, am I getting? For this? What? Are you able to check or not?
Ma'am, we will read it again
Ma'am.
in
No.
tomorrow.
My question is, see, my starting state is this, my ending state is this one. I want to stop and repeat the same thing. So this one is a preset. I want to stop after this means, can I connect every output to an AND gate and then check, because here if I do all the AND, every time it will come 0 other than this one. Will that logic work? Clear will be changed? That is what I was asking.
Ma'am, I have a doubt, ma'am. From 1010 to 111, we have 6 states, I think. So shouldn't it be mod 6?
4, 5, 6. Oh, okay, mod 6. Understood. Mod 6. Oh, there you are stopping. Oh, you're worried about that number. See, that's not the criteria. I was thinking which gate has to be fiddled with the clear. That's what I was thinking, and you are with the. Oh God. Okay, mod 6 counter. Starting with that and this one. See, you only have to stop the show. You have to preset it and stop the show, no matter whichever gate you use. Okay, so I think this is the best way. Because just see, in everything, whatever AND we will do, all the things will be 0 other than this particular one. So at this level, every output is 1. When we AND it, we will get output 1. So your clear will have a changeover state. So then again it will be freshly input the starting value. Okay, so check out. Right, I think you need to go. Right, and no problem. Check out once again. Right. Thank you.